Okay, hello everyone. This is a bit of a workshop to sort of tell you a little bit of how to write cleaner code with MATLAB. And another title I could have given to the whole thing is things I wished I knew when I started coding with MATLAB. And if you find this title hard to read, well, that's just to kind of illustrate the whole point of the workshop is that very often the code we encounter is very hard to read, and hopefully after sort of following these few videos or recordings, you have a couple of more tools in your toolbox on how to write cleaner code in general. Okay, so the goals of the workshop. Overall, hopefully by the end of this whole thing, you will be able to sort of improve the quality of the code that you write. That's, I would say, sort of the main goal. So as a side effect, hopefully you gain confidence in the code that you write, and you'll feel sort of more confident sharing it with others. Another side effect that comes with all of this is that you're going to learn a whole bunch of transferable skills, and they are transferable in different ways. So first of all, a lot of the things I'm going to show you today are not specific to MATLAB. They can apply to Python, they can apply to JavaScript, and also in general to most programming languages. So once you've learned some of those skills, you can definitely sort of start applying them if you either know another language or learning another language. And finally, they're also sort of transferable in the sense that those skills are very valuable outside of academia. So if any of you is thinking of after their PhD or after his postdoc to start a new job outside of academia, and that this job may have something to do with programming, a lot of the things I'm going to show you today either are sort of like taken for granted, and everyone expects you to know these things, or if you know them, it gives you some sort of advantage, or you'll be able to sort of keep the road running more definitely more easily than if you didn't know these skills. So what's on the menu for today? I've split the whole thing into different parts. First of all, I'm going to sort of show you how to sort of test your code. I'll explain a bit later why I want to start with this section first. Then I will sort of show you some very general tips on code formatting and how you can make it easier in general for you when it comes to formatting MATLAB code. Then I'll talk about refactoring code, and in that section I will actually explain what refactoring actually means. Then I'm sort of going to try to give you a whole bunch of tips on how to sort of get better self-discipline on how to sort of apply those rules in a very systematic manner. No, actually, I'm not going to do that. I'm going to show you a whole bunch of things that you can do to sort of automate a lot of the things I'm showing you, so that actually you don't have to sort of be very good with self-discipline, and you can actually just let either the computer do it for you, or sort of make it part of your sort of workflow in general, so that you don't have to sort of remember to do those things all the time. And finally, if we have the time, I might show you a couple of things on how to sort of structure your projects in terms of where to put your code, where to put your data, and so on. So the format of the whole sort of workshop is sort of divided, is sort of organized around live demo, where I will show you how to do some of the things that I'm talking about. And more specifically, it will be sort of a live sort of code review or a live sort of code cleaning, sort of where we have a sample of code and we apply some of the things that I'm explaining directly to that code sample. And ideally, if you have time, you can sort of either try it on your own, or stop the video, either try it on your own code, or actually sort of try it on some of the provided codes, so the code sample, or part of the GitHub or GitLab repository that goes along with this workshop. So yeah, it's going to be a live code review. So this is one of sort of illustration of how you measure code quality in general. And good code and bad code sort of mostly differ by the amount of expletive and sort of swear words pronounced by the people who are actually having to review the code. Just sort of warning that you might hear me sort of complain a little bit about the code that we are going to review together. So that's one thing. And so, yeah, and actually to tell you whose code we are actually going to review, well, it's actually going to be mine. And this is how it's going to go more or less. So I don't know if you know this webcomic, comicstrip.com. If you don't know it, that's pretty much your homework for next time. And the idea is that this is pretty much the situation we are in. You're going to complain. I'm going to complain a lot about the code that I actually had to fix. And what I wish I could do is just jump into a time machine and visit my past self to sort of tell younger Remy about all the good things all the good tips that you can sort of use on an everyday basis to sort of improve the code quality so that your future self doesn't have to sort of maintain horrible code in general. Why am I choosing this format? That's me from 2012. I just was starting programming in MATLAB, and I knew about what an if block is and what a for loop is. That's about it. And why am I choosing this format? Well, first of all, I want to sort of give a very concrete example that we all have dirty code. So this is going to be a code sample from me from about 10 years ago-ish, more or less. That code is actually on GitHub. It is part of the sort of GitHub repository for this workshop. It is also part of the project that we published a paper on. So it's just to also say, yes, sure, your code is dirty, but this might not be a sufficient reason not to share it. And also, especially what I want to show is that even if your code is dirty, there's plenty of ways you can sort of use and put in practice to improve it. And by improving it, then you make it more likely to, at least you feel more confident and comfortable sharing it with others. And why sort of a live demo aspect? Well, it's mostly to show what coding is in real life. And that, even the people that you might think are much better than you at coding spend their whole time Googling stuff because we don't all remember all the things. And we do copy-paste things from the internet like everyone else. And before I move on to the first section, I want to sort of mention a couple of references you might want to have a look at in your own time. Those two books, the first one, The Art of Readable Code, and then the other one called Clean Code, I would say are definitely very good go-to references that sort of touch upon a lot of the things I'm going to be talking about today. The first one is definitely an easier sort of entry point, at least, for the whole thing. And whereas the second one has a lot of sections that are fairly sort of easy for, many people, even if they don't know a lot of programming, but definitely some sections or some of the concepts that I talk about are definitely a bit more advanced. And one thing that they both have in common is that none of them use examples of MATLAB code. But I would say both of them makes a pretty good job at sort of using examples that are fairly understandable, even if you're not like a wizard when it comes to programming. The code snippets are pretty short, so you should be fine sort of being sort of understanding what the authors are talking about. So that was it for the intro, and now we're going to move on to the first section. So we're all about testing. And the way I'm going to run all of the sections, I'm going to sort of start with a series of questions for you to answer. So first, first of all, who here or have you ever put code on GitHub or GitLab? Then I want you to think is when you put your code on GitHub or GitLab, do you sort of keep it in a private repository because then no one can see it, or do you put it sort of in a public repository? And sort of attached to that, if you have, published a paper or a master thesis or, PhD thesis, whatever, have you shared the code that goes with it? And, if you've answered, so like, yeah, if you haven't not answered yes to some of this question, I want you to reflect on why you've not done it. And maybe I want to sort of point at this fact that, ask yourself, have you ever been in this position where you told yourself, I need to clean my code before I can actually make it public, and then you've actually never taken the time to do it? If that is your situation, just remember that this is the situation of most people, and we all have a lot of sort of insecurities regarding the quality of our code. But I want to show you today is that there are many ways you can sort of, a lot of tips you can sort of put in practice on an everyday basis to sort of get into a situation where we don't even need to clean your code. And that therefore it sort of lowers the sort of the psychological sort of stress you might have regarding code sharing. Okay, so first of all, we're going to talk about testing code. So why test your code? Well, one of the reasons why we don't clean our code very often is especially when you're at the end of the project, you have your results, you're writing a discussion, and everything is ready to go. But you want to share your code and you need to clean it. And then comes the problem that, if you change your code, or sometimes someone else, then you are, you're going to mess things up, and you're going to sort of potentially add a bug. So in the worst case scenario, in the sort of the most obvious scenario, you will break the code won't be able to run, and you'll be able to sort of see that something broke, right? But another possible thing that may happen is that the code still runs, but it gives you different results. So how do you get around this? Because now you want to make sure that the code that you have will always give you the same results, right? But you still want to sort of be able to sort of change the code, but ensure they will always give you the same results. Well, that's where tests come in. Tests are a way there are two things you can do, to get around this problem. First of all, use Git. And Git is a way to sort of version control your code. So if at any point you make changes to the code and it gives you different results, you can always sort of travel back in time and go back to a situation where the code gave you the results you expected. And the other one that goes with it is tests. What is actually a test? Sort of in a very sort of simple way, tests define the behavior of your code. And what I mean by the behavior, or what we in general mean by the behavior of your code, is the following thing: is that your code is going to have a whole bunch of inputs. Most of the time it's going to be some data, but if you take a single function, for example, it's going to be a series of arguments with specific values. And when for this given code and this given input, you are going to get specific outputs. So usually sort of, the function is going to compute some things and return a certain value, right? And the behavior of the code is the relationship between all those inputs and the specific values that they take, and the outputs that they give you, right? So this is the relationship between input and outputs, and pretty much not caring about what's happening in the middle. So we don't really care about how the code is actually implemented. We just care that for those inputs, that function will always give us that output. And this is the sort of relationship between input and output is how we sort of define the behavior of the code. And tests allow you to sort of define that behavior and sort of lock in place this relationship between, if I give you this input, you're always going to give me this output. Okay. And now to move on to something a bit more sort of practical, I'm going to show you how you do a little bit of testing. Okay, so now I'm actually going to show you some example of testing and try to sort of give you a slow introduction to testing. First on some sort of, let's say, dummy examples, and then sort of trying to show you how you would start implementing tests on sort of a code base that you already have. For example, your project that you have, you most likely have hundreds, maybe 1,000 lines of code, and now you need to add tests to everything. So for this, I'm just going to move on to the website I created for the workshop. Let's go to the testing section. So here on this page, you already have some examples of what this could look like. But I'm going to sort of recode some of that so that you see how it will be done. So the first part to sort of write test, let's say that we already have some function that we want to write a test for. So this function sort of will take some input and give us some output. Okay, here I have an example of a function that add two numbers. Let's try to do something a bit different and have a function that's actually going to multiply two numbers here, just to vary things a little bit. Okay, so let me start MATLAB. It gets things started. Okay, so let's write here. Let's just create a function. Log numbers. So let's simplify things a little bit. We're going to take some of the default that MATLAB gives us. Let's expand. So at the moment, just with the most variable version that we can have. X, Y, and Z. And I give it two numbers, it just has to multiply them, right? So good. Okay, so that would be a very, very, very simple function that we need to use. Actually, maybe I just realized to make this a little bit easier to read. I am going to make the font a little bigger. Nope. Font here. Sorry. So that everyone can see where easy it's going to be. Okay, that should be easy to read. There we go. Good. Okay, so we have created our function A. So now that's the first part. That's easy. So using assert would be sort of your first line of defense when you are testing code. Assert, I'm actually going to demonstrate how it works because that would be easier. Is assert works in this way. If I pass the value true to assert, nothing happens. If I pass the value false, assert fails. So that's pretty much the only thing that it does. If you give it something that's true, nothing happens, and if it fails, it throws. If you pass it something false, it throws an error. And you can even send a message here, assertion for X failed. So there you have a slightly different error messages. How that can be used is to check things in your code within a function itself. So for example, what we can have here is that we only want to multiply scalar values, so we don't want to multiply matrices. So we want to make sure that the number of elements in X and or Y is equals to 1. So you can just assert number of elements in X equals 1. And then have a specific sort of error message. Elements in X must be 1, which not 1, not 2, that's like 1. So that is something we can do, for example. And then we can do the same for Y, exactly. So this would be how you would use assert, for example, to make sure that your value is sort of, you check that the values you pass to your functions are appropriate. Another thing you can sometimes have is that you know that the value of Z for whatever reason must be positive. So you could have another sort of assertion in the middle that goes assert Z equals superior to 0, and then in this case you don't have sort of assert like an error message. But this would be how you can sort of add some checks within your code to sort of catch potential errors. So I'm going to sort of demonstrate how this would work, but in this case, if you have the case where this is fine, this works. Here we have cases where this is fine. Here we can sort of, let's say that we pass the matrix, and here we're seeing that this triggers this assertion because we've passed a value for Y that is not a scalar, but it's actually a matrix. So, I mean, in this case, a vector. So this is some sort of thing you can already start dropping in your code to sort of checks that some values don't take some, some like variables don't take some crazy values or something. For example, if you know that your analysis should always have, I don't know, 25 subjects, you can have some sort of assert that the number of subjects included or the number of files included equals 25. And if you don't get that number, it should like throw an error somewhere. So this is sort of the basic approach of how to use assert within your code. So test your code as it is to sort of make sure that it behaves properly. So the next thing that we're going to want to do is write what can be called a smoke test. So we're going to start writing actual tests. So tests are code that test code. That's so to do this, the way we would do it in this case would be to sort of create, or actually it can just be a script, and we could just create something called smoke. Well, actually, we usually either when you start writing tests, either they are test underscore something or smoke or like something underscore test. So that depends on sort of the style you prefer, or sometimes you actually have to use one or the other. So let's write a test smoke. So the way a smoke test works is it basically just make sure the function runs at all. So you give it some input and you run the function to make sure it doesn't crash. Right? So that will be, in this case, we go, the most simple smoke test would be, for example, what we had done before, right? So we have this, that would be sort of the smoke test for our function, or you could have something like this, and those two things, for example, this little script would be considered like a smoke test of our multiply numbers function. Okay. And so here, this is sort of another example. Instead of having a script, I actually have a function that itself calls this other function. So now we move on to unit tests. So unit tests are a bit more constrained than smoke tests. Smoke tests just make sure that the code runs at all. Unit tests have an extra little thing on top of that. So you pass to your function some known input, and the function in this case is going to return some output. And what you're going to do in a unit test is that you're going to sort of compare this output to what you know is the expected output of this function for those inputs. So you sort of compare the two and you sort of make sure that they are equal. So if you want to write a unit test for this, this would be a bit like this. So let's create a new script, and we can just call it test unit and open it. So now the way we do it, let's take actually those two examples and turn those just pure smoke test into sort of unit tests. So the way you would do it for here, for example, would be assert. So assert that z equals. Oops, no, we multiply the two, so it's 2. So that would be sort of a first unit test, and that would be a second unit test where you make sure you sort of give some known input to your function. It returns a certain value, and then you compare the sort of output to what you know is the expected answer for these two inputs. And then you can just run this, and it sort of tells you that those are the right values. So this is pretty much what a unit test is. You have some known input, you pass it to the function that gives you something in return, and you check that what it gave you is actually the right answer. So this is pretty much just what a unit test is. And one thing that is important when you start writing tests is that you may want to test your function against a wide range of inputs. So just to make sure that the code behaves properly in many different situations, right? So, for example, what we could do here, instead of having just those two values here, you can totally do and write test this way, which is you can have x equals, let's say, 2. Let's always keep x constant. Let's have y equals 1 and then 2, and then expected results, expected z equals 2 and then 4, and then you can have 4 let's call it iy equals 1, so all of the elements in y. So let's remove this. So you can just create a loop to test all the possible values. Oops. Say this is expected y, and here we have y, iy. And there you should have a test that allows us to sort of test a whole bunch of different inputs in a more, we're going to have to copy paste the code very often, and that sort of checks a whole bunch of values. If we want to check some other values, we can just do something like this and add and test a whole bunch of values like this. And for example, we could also say, hey, actually, if this is 0, we could make sure that our the value here is going to be 0, right? And oh, actually, this is how you see that we have some where our assertions are in the code are useful, because then sort of it's already telling us that we are testing things that are not possible, or given the sort of the behavior of the code that we want. So let's just remove this. And this is how we have defined the code of our little function here by writing that series of tests. So yes, this is pretty much how you would write unit test. There are some other examples in here that I sort of have created for some other sessions. You can sort of see how you sort of write a given function and then add tests for it, for example. Then I'm going to sort of tell you how you would use a given testing framework to automate and sort of help you run a whole bunch of tests for your code base.
So now what I'm going to show you is that there are tools that you can use to make all this testing a bit more sort of practical. To how you organize your files, your testing files, and how you can run them more efficiently. So, first of all, these are called like testing frameworks, and MATLAB. I think more recent versions of MATLAB do have their sort of built-in testing framework. I'll give you an example how to use it. I tend to prefer sort of an external toolbox called MoxUnit for that, but when it's on your own code, feel free to use whatever you feel most comfortable with. So the way those functions are structured, because I have no memory and I need to sort of I never remember that by heart. Usually what I do is go and grab the examples, the top function from somewhere else. So actually, no, let me just put that into another file so that we start. So so this is pretty much what you would need to have at the top of a function if you want to run your test using MoxUnit. This is something you can just pretty much copy paste. The only thing obviously you can change is actually the name of this function. Here we are testing the create participant file function, so it's usually better to just name it like this. One of the only requirements you have is that the file name and the top function should start with test underscore. So that's if you don't name the file like this, MoxUnit will not sort of recognize it as a test and will just skip it. So that's like the first requirement. The other requirements is that all your tests after that have to be in subfunctions. And each of those subfunctions has to also start with the name test. So here we should have our first subfunction should be test, for example, that's our smoke test. So we can just have it in here and have it just like this. And then we can do the same and put all our unit tests we created before. We can sort of add them in here as separate subfunction. So that was test unit 1, for example, and that's fine. Oops, test unit 2, and nope, it has to have a different name, otherwise we're going to run into trouble. And here, okay. So this is pretty much how you would sort of structure things into, if you want to run your test with Mux unit, you just put everything sort of, for example, into a single file and organize all your sort of individual tests into subfunction. And now if Mux unit is in the path of MATLAB, you should be able to sort of just run things by just clicking this file. Okay, it's not super impressive what's happening here, but we're getting 1 dot for each subtest, so for each test that passes. And if one of them fails, I'm going to show you what this looks like. I'm just going to want to silence this output here. So good, right. So all the tests pass, but if at some point, let's say I change the expected value for a given test, now we're going to get only 3 dots because only 3 of our tests passes, and the last one is a capital F, uppercase F, because it fails. And at the end, you get a report of all the failures, and it's telling you that your third unit test failed, line 32 on this assertion. So it's kind of a way to sort of like quickly sort of run all your tests and get some feedback for this. Another thing you can do is, let's say that this is kind of annoying because then you have, let's say, several files. Imagine you have 10 different files with tests in them, and now you have to open each of them and then click run and then go to the next one and click run. This is not very efficient. So another way to do this, actually, I'm going to show you. Okay, let's actually. Yeah, I'm going to keep those for now, but I just want to show you how it's more efficient to do it slightly differently. So I'm creating just a copy of the same file. Here I'm adding some more tests, 4, just as an example. We're removing this one here. So here, for example, now we have 2 test files that contains test for our function, and manually you would have to open this one, run it, it passes, and then open this one, run it. Oh, now we get a failure. Actually, yeah, remember that now I should actually fix this. So now this passes. Okay, cool. But now we have to open each file, not very practical. So the way Mux unit works is that you can just directly type Mux unit run tests, and it will detect all the files in the current folder and then run all the tests on the current Mux unit tests smoke. Oh, yep. It will also detect that some of those files are scripts, and they should not be scripts because Mux unit is not happy with scripts. You know what we're going to do? We're going to delete this one because we have moved it into an actual function specialized for this. So let's also do the same with the test unit so that Mux unit doesn't complain. Okay, and now hopefully, yes. So now it has run all the 5 tests we have in all our test suites, and we're happy. So right now, kind of easy because we only have 2 files. We could have done it manually. It's the more tests you write, the more sort of unpractical it becomes to run them manually. So having this kind of function is kind of useful. Other thing that you can do is start passing argument to this, so you get a bit more information of what is happening. If you have like a verbose mode, it will tell you, hey, it will give you the list of tests it's running and whether the test passes or fails. It will also tell you how long it takes for the test to run. This is kind of useful because ideally what you want to do is you want to run your tests very frequently, and therefore they should run really, really fast. Why is that? Is that, remember that we're writing tests to make sure that the code does what we expect it to do. If your tests take 2 hours to run, you're less likely to run them, right? Because no one wants to wait 2 hours to make sure that their code functions properly. And so if your test suite starts running very slow, you're going to start not use it, and then you're going to start changing your code without testing it, and you're going to introduce bugs, and then your results are going to change, and then you're going to start crying because nothing works. So make sure that your tests are super fast. So that's why getting an idea of how quick to identify which tests are running slowly can be a good sort of pointer. Like, I need to make sure that this test runs faster. Okay, so that's one thing to do it with Mox unit. Now, oops, this one is not happy because it doesn't have the right name. There, fixed. Next, let me show you how you would do it with just using MATLAB. So I'm going to take this file and make a copy of it, but I'm going to rename it just MATLAB. If I can type, that would be better. Oops, no. New. Where are you? There. Cool. So let's close all the other ones. And nope. So there are a few things I need to change, and I don't remember what they are. So this one has to go. I think this one has to go. I think I'm going to have to go and look at how it's written, because I never remember. Give me a second. I'm going to go and check at how I did it yesterday, because then it's easier. There. That's how you do it. So tests and return test. Okay. Like this, and this returns this. There. Good. Oh, yep. You need to call this one MATLAB. Where? Good. Oh, yeah. And actually, what's useful for this one, I want to have more than one test in here so that you see how it works. Test number 5. This is going to be face. I'm making things up now. Just let's say it's a face repetition task. Okay, good. So this is, actually it's not, test case, because that's how MATLAB likes its test to be written. Okay. Yeah, I think that's pretty much fine. So it's just slightly different. The logic is the same. Each test goes into a sub-function, except now that you need to have like the test case argument into it, so that MATLAB recognizes this as a test is supposed to run. And the top function is just slightly different. But except from that, it's pretty much the same idea. The only difference you might not have noticed is that, okay, so this is a test with Mox unit. It looks like all the buttons you have here look pretty much like the usual things. There is the run button for running a function or script. But if it's written as a MATLAB test, you see that those buttons are slightly different. Here, MATLAB recognizes this file as a test file. So you can either run the whole thing. It does take a bit longer to sort of run the test, but you also get a report like this telling you which tests have passed, failed, incomplete, the duration of each of them, and so on. So you get some statistics as well to sort of also identify the slow tests. I think the second time should be faster. Yeah, the first time is always a bit slow because it needs to sort of load a few things. The next time will be faster. One cool thing about running tests with MATLAB testing framework and not Mox unit is that you can also run individual sub-functions. Meaning you can run individual tests because here you have a different button that will realize where your cursor is, and you can say, hey, just run this test or just run this one. Whereas Mox unit, you kind of have to run the entire file. So sometimes that's a bit annoying. But that's pretty much the two ways you could have run tests with MATLAB, either using sort of Mox unit or MATLAB testing framework. So you pick and choose which one you want to do when you're testing your own code. I'm not going to decide for you. I'm not going to tell you. But one thing we may want to do is working with code coverage. So code coverage is, let's say that you have crazy amount of code. You have like 5,000 lines of code that you've written for your analysis, and you've written a whole bunch of tests for it. But code coverage is the idea that once you've run all the tests, it will tell you which lines of your code have actually been run when you run the tests. So let's say that I'm going to give you a very simple example of a line that would never be run no matter how many tests you write. It's this one. If false, display file name. No, file name. So this, for example, will always be false. So you will never enter this if block, and therefore this line of code will never be run, right? So no matter what test you write, this thing will never be run. So your code coverage will tell you, oh yeah, I can run this and I can run this, but I've never been able to run this. So this is a silly example, but when you get a report about the code coverage, you can identify which part of your code have not been tested, and that's pretty much where bugs can go and hide, right? So the idea is that you run all your tests, you identify which part of the code are not tested, and then you write more tests to fulfill all the conditions to just hit those specific parts of your code. How you could do this with Mux Unit is, first, before I do that, I need to arrange this, the way this is structured a little bit, because it's going to become, because I'm actually going to need it to run the coverage. So usually the way you organize your code and your test is that you literally put them in different folders. Here we have everything into one same folder. When you start having a lot of code and a lot of tests, ideally you want to sort of separate them and start organizing them in different folder. So here I'm going to do it with a source folder where I'm going to actually put the code that I actually use for my analysis, for example. And I'm also going to create a different folder called tests. And I'm going to put all of those in there. OK, so now I have two folders, source and tests. And then I think I'm going to be reusing stuff from yesterday because I don't know it by heart. Yes, that's the one. Let's just do this. Well, actually, I can copy it from here. So we're going to create a function, actually a script just called run tests. Oops. And this is how we're going to do it. So we're reusing the Mux Unit run test function that you've seen before, except now we're passing it more arguments. First of all, we're telling it this is where the tests that we want to run, this is where they live. So they live sort of in the present working directory in the test folder. This is the code that we want to cover, so where our actual sort of analysis scripts and function and everything lives. And so we're using sort of the verbose argument, I think recursive. We don't exactly need it for now. With coverage is this thing is like, okay, give me a coverage report so I know which files, which part of my tests, of my code have actually been hit by my tests. And this is where you output the coverage report as an HTML file. So let's just run this. We're getting a whole bunch of information. We're getting, oh, it's also running the MATLAB stuff as well. Sure, why not? Not going to complain. And also here I've created a coverage HTML folder that we can open the index, and it makes a list of all the sort of code file that you have, and it will give you sort of a report of all the it will give you sort of, it will print the function itself and show in red all the parts that have not been touched by the test. So indeed here there is this if block that's always false that shows up as red. In this case we can't really write tests that will ever hit this, but maybe I can try to give you sort of a slightly different examples here. Let's say that Subject number, every time we test it, is a string, right? So let's just go and say if subject number, if is numeric subject number, then we go subject number equals num to string. So we convert our subject number to a string, and then we can use that to create our file name, right? So if we rerun, if we rerun all our tests and check our code coverage, we should see that this line is never been hit by any of our tests, right? So what you can then do is, okay, I want to make sure that this thing actually gets checked. So now what I'm going to do is that I'm going to add a test where I don't need this. Oh, that's not the MATLAB one I want to run. Sorry. Go away. So what are we going to call it? Sometimes it's kind of better to start giving even your subtest some sort of meaningful name, so that when they start failing, you sort of as a number. So here, for example, we're going to pass it a number, and therefore we should expect that the output should look like this. You can sort of run it sort of individually. Oh, yes, that's something that I forgot to mention. Why is this failing? Because now all those the create participant file is unknown to MATLAB, because it's no longer because the test file and the code we're trying to test are in the same folder. So if you want to run the file individually, you would have to add the source folder to it, and then rerun this. Okay, all the tests passes, and if you run all the tests with the coverage report, our 8 tests pass, and if we refresh this, now we see that this line has also been tested, right? So this is pretty much how you identify the part of your code you've not tested and write more tests to make sure that all parts of your code do behave as expected. Okay. Are we good? Do you want to have like 5 minutes to try to implement some of that, maybe? Yes, you have questions.
Yeah, I was wondering, so how well this testing works really depends on how good I am in identifying all the possible cases, all the edge cases,
yeah.
and all forwarding, right?
Yeah.
There's no way to, probably not, right? So I'll automate it in any case, right? Assume that has a whole bunch of, possible cases.
So yeah, the idea is, so first of all, start with the obvious one. So like what some people call the happy path, like the obvious thing that your code is supposed to do. Then go for obvious edge cases, like testing 0, testing in negative values, and things like this. Then it's also up to you to decide what, sometimes you go like, the way my code is structured, this function will never get this input. Like there's no freaking way that it will get a string when I know that every time it should get a number, right? So there are some, it will depend on sort of you to sort of figure out what are the good and bad cases. I don't think there is any way to automate like testing a whole bunch of cases. What you can do though is have things, especially for something that simple, what you can do is, I don't know, you can do, run numbers equals, I don't know, you can test a whole range of values, right? From -1 to so from -10 to 10. Okay, here it's a bit of a silly example because we're just creating a string from that. I equals 1 to normal, just. And then you test run number I, right? So you can always like you can start having like loops and stuff to create like a whole series of tests rather than writing like a bazillion unit test on this, right? And then you can sort of make sure that this thing sort of still works, right? Okay, no, apparently it fails, but because I obviously can't do MATLAB that early in the morning. Yeah, so that would be one way you can sort of start testing a whole range of values. Up to you to decide which values go in there, but you can create definitely like loops and things like this to sort of like automate some amount of testing, right? That would be one obvious way, for example, but yeah, it will depend on test case, and so what are edge cases depends on the specific code you're testing as well. Does it make sense?
Yeah.
Okay, cool. Awesome. Do you want to have like take 5 minutes to maybe try to run some of your tests with MoxUnit or one of those two? Yeah? Okay, let's take 5 minutes then to just try this. We're not taught about testing. That's what most of our code is because we don't have tests for it. So like you all work with legacy code and that's fine. But eventually when you want to sort of add tests to this, there's like a few techniques that you can use. And I'm going to show you how I would do it on some very old code of mine that I mentioned earlier. But I'm pretty sure that some of the things I will show you, you could also apply to your own code. So what I'm going to do first is go and grab the code and the data in question so that I can actually run it. So the code and data are in the repository, the same repository where the website is. So I think you should have the links available if you want to try it. So I'm just going to copy those things into the folder where I was working today. I'm going to create a folder called legacy. So here I have my code and my data. So that's the first thing I want to do. And then what I'm going to do is sort of start adding tests for some of that code in here. So just for the context so that you understand a little bit what this does. It was an experiment I did sort of like 10 years ago. And the idea is that, I don't know if any of you is familiar with what's called the McGurk effect, but it's those movies where if you see someone say a syllable and the soundtrack is like a ba, but the lips move by saying ga, your brain just mixes the two, and what you actually hear is like a da, right? So that we were playing around with those things and checking what people were hearing, depending on sort of like the context that the movie was in. And so I would show people a whole bunch of those movies in the MRI scanner, and this is one of the scripts. So this would be like this analyze function, which sort of take the output from all the runs from a given participant, sort of compile all the data into a single sort of giant cell, MATLAB cell, so that you have all of things, and just compute the reaction times and give you some statistics about it, and then save a single file at the end. So if you run through the whole thing, it's kind of painful, but what it does is loop through all the runs, loads the mat file from each run, takes the trial variable from this run and sort of adds it to sort of a total trial sort of cell, and then it plots some figure for reaction time. Here I think it's sort of compiling sort of what the responses are for each of the movie that you use. I think then it goes through all the trials that you have and checks what responses were given for each trial, making sure that it classify them as good or bad responses and so on. Then it displays some stuff on the screen so that you get an idea of how well the participant did. And then it adds more figures. And then eventually at the end, it prints all those figures either as a postscript or as, don't remember, like it's a vector format, so EPS or SVG or PDF, depending on what you want. And it would then take all the compiled results for that participant and save it into a single sort of mat file, right? So you have all the data from that single participant for all the runs into a single file. And the way I would run that in the good old days is that I would sort of, first I would make sure that this folder is in the MATLAB path. And then I would need to click, go to the first participants folder, and then run the file from there, run the analyze file from there. And then it would just print a whole bunch of stuff, and then it would just create my figures, and it would sort of save a single, you would save all the figures in there, and save a single mat file that has all the information about all the runs of this participant, right? So first thing we can do is just make sure that this code always runs by writing a smoke test. So instead of having all this clicking and changing folders and stuff, we're going to create a single file. We're going to create, a smoke test that does all of this automatically, right? So actually, let's go up. How are we going to call it? So test, analyze. Forget about that for now. Test, oops, replace. We don't need any arguments, we're good. So what did we do manually? I had to go to this folder. Oops, I had to go to this folder. So it's pretty much change directory into here. And then I just had to run the analyze function, right? So that's pretty much what I just had to do. Okay. Apparently, technically, that should be pretty much like enough, like the bare minimum as a smoke test, right? So you just run this, and that is like a small function, a small smoke test you can sort of keep reusing to make sure that the function at least runs, right? But that's not good enough. Remember, we want to make sure that our results don't change, right? So we need to make sure that the output of this function is also stays constant, right? So that's why we move from a smoke test to something that resembles more like a unit test. So there are a couple of things that this, yeah, you have a question?
Yeah, so here, analyze automatically detects the MATLAB file called analyze.
No, yeah, actually, technically, let's actually do it. You're kind of right. Let's do this. Let's do things a bit more cleanly. Let's dip. So let's remove this from the path, and let's do it properly. So first of all, we're going to put things into a test folder. We're going to move this into the test folder so that we have things that are sort of well organized from the very beginning. Just like before, we're going to create a run test function. Let's just be lazy for now and reuse this one. So things should be pretty much the same for here because we have the same folder name. All the tests are in here. Source is in here. We'll get a coverage report as well. This is kind of nice. The thing we need to do, though, is we need to make sure this is structured as a mux unit test. So let's just grab the heading, the top function from there. All right. Okay. Nope. You need to be named test analyze, and this is a smoke test. Test analyze smoke, right? Cool. So now if we go back to our legacy folder and run this, so now the code folder is not in the path, so we don't even need to add it manually, and everything should be automated by mux unit. Hopefully, or not, you know, sometimes it doesn't happen. Mocov find file first should be what? Ah, yes. It's not a source folder, it's a code folder. So that's why you get an error. Okay, so now we didn't even have to add it to the path. Mux unit sort of like, oh, this is where your code lives. I'm going to add it to the path and runs everything automatically. Oh, by the way, we're also getting now a coverage report. So we can also see that which part of our code is being run by our, so first of all, we can see that there are some parts of the code that are not being run, like ever. So all of this, for example, never gets hit, but most of the function actually just is hit, and sort of like we see that most of our stuff is actually getting executed. So that's actually not too bad, to be honest, with just a smoke test. But where was I? Ah, yes. So we have a smoke test, but we are not checking the output of the function, right? So if we get different results now, we will not know it, right? So very basic things in terms of what is the behavior of this function is that, first of all, it does create some figures, and it creates this sort of results mat file, right? So there are a few things we can do. So first of all, let's write this in a way that's a bit easier to work with. So we're going to have our data directory is going to be this one. Let's just make this a little bit easier to work with. That's our data directory. That's our subject directory is a full file data dir sub 01. Cool. So we just want to move to the subject directory. So far, so good. And then, so this is sort of the setup. And then we want to actually add tests. So we want to assert a couple of things. First, we want to make sure that this figure file gets created. So we can do exist. So the way we want to do this is full file subject dir. Oops. So that's good. Then exist is a file. And then we want to make sure that, so yeah, if you've never used exist as a function, when it returns 2, it means it has found a file with that name, right? So here we're just making sure that indeed the file got created. Let's see if that works. Oh, yes, because I'm running it just like this. Let's run it just through with the whole mux unit thing. Hopefully that should work. Oops, did not. Why did it not work? And that's when you have to sort of sometimes, nope. So I'm putting a breakpoint here so that it's going to stop right before I run the assertion. So does that make sense? Nope, it doesn't make sense because things are in the behavioral folder, not just this one. So behavioral folder. So now it should be fine. So you see how running this function already is taking a bit too long, and you're already tempted to not run it that often. So this is definitely one of those things. Make sure you test run quickly, otherwise you're very tempted to not run them. So if you just keep on running this, yeah, the test passes, so we're good. So okay, we are starting to test the behavior of the function. It is creating figures. Cool. Okay. So the other thing that it was creating was this results file, so we can also check that this exists. Hopefully this should run as well. We should be good. And while this is happening, I can already tell you that something that you want to do with your test is that if your test creates some files, you want to delete them afterwards, right? So for example, when we run this test, we actually are creating this figure file and this mat file. So the thing you want to do after that is sort of delete them, right? So what you can do is delete this file, and then delete also the output here, right? Oops. So to make sure that you always start and end pretty much from the same situation, so that whatever was created during the test is deleted at the end of the test, right? Nope, that's not going to run. Go through here. Okay, so now it has deleted sort of some of those things. So we're trying to sort of test the behavior. But now we're just testing what files were created, right? So, not ideal. Like, we don't actually test what values we're actually getting. So if you want to start doing this, then what you need to do is, well, first of all, you need to have some sort of reference what all those values are when you just run the function. So let's temporarily just run this and get the output that you would normally get with the function when you run it normally. Okay, so we have this results file here, which contains all the expected value that you have if you run your function normally. So we can just call that, we can just rename it and call that expected results. And then in our test, what we're going to do is that after the function is run, we're going to load the expected results. So it's going to be, nope, something like this. Load full file, expected results, yeah. Yes, and let's load that into a variable, a structure called expected. That's nice. So now we're loading all the expected results, and then what we can also do is load all the actual results created by the function, which is just contained into this file here, and we call that just results. And now we just need to compare that the results we've just computed are equal to the expected results. So right now we're just creating sort of, it's kind of obvious that this is always going to be the case now, but the moment we start changing our code, this may not be true anymore, right? But at least it gives this sort of relationship between the input and the output that we had, that we want to have when you want to run proper tests, right? So the weight, sorry, that was, yeah, sure.
So when we are saying 2, that's like it's checking after analyzing that this figure is generated
that the file exists. So actually, let me show you. Maybe let me give you a demonstration. So actually, if you're not sure, just in case, go type help exists. So exist will return one of those values if whatever you've given it doesn't exist. If 1, if it's a variable that exists in a workspace. 2, if it's a file with one of those extensions, and so on, right? So 7, if it's a folder, and so on. So it's just a very generic sort of function to go like, hey, is there anything that MATLAB knows about that has this name, right? So 2 is just that we know that it's the file that we're looking for, and that's why we just check that this value equals 2. Okay, there's one bit of a problem with doing this. So that's a good idea to check the content of those two things, but if you load any of them, so if you load this thing, you realize that it has a bazillion values in it, right? And there is the only sort of, not the only, but the most convenient way to check all of those values just in one go is just to use a function from Moxunit called assert equal. And it will just check all of those values all at once. So you can check that the results that you have created are equal to the expected results. So let's Okay, run all of this. I'm just going to put a breakpoint here just to catch it when it's running. Just to show you what is the content of each of those structures. So expected results is a structure with 1 million fields in it. So like, yeah, if you just look at the content, it's got all of those values. And results is pretty much sort of a similar structure with all of those values. And now you can sort of just run this and make sure that the content of the two things are the same, right? So that thing runs and your test passes. So now you have creating a unit test that will ensure that whatever you do to your function, if you change its behavior, you will know it. So now you're kind of ready to go and clean your code and go completely crazy and just try anything, because you have this checkpoint you can always go back to and go like, whatever I do, I know that I can always go back there and start from, you know, and make sure that the results of my paper are always going to be what they are. Make sense? Okay. I think I'm going to stop here for this first part because there was already quite a bit. What did we do yesterday? We sort of had a break and then had a lunch around noon, right? Something like this. So maybe we can do the same. Let's have like a 10-15 minutes break, and then we continue until noon, and then we break for lunch again. The next part will be definitely quicker.
Okay, so yeah, I'm going to quickly show you how you would use mishit and to help you sort of format your code. So see it here in the formatting section in the website. First of all, you sort of need to install mishit. Let me try to make this a little bit bigger so that you can better see what's going on here. So mishit is a package, so you would just need to do it in this instead of mishit. I already had it installed on my system, but if I didn't, it will install it this way. And mishit comes with different tools. One is this sort of a style checker, the other one is a linter. And we're going to start sort of running those to sort of start cleaning up our code. And how we do this is, let's first try to see how we can sort of apply for the styling sort of tool of mishit. So for this, you just type mishit style and style. And then in the dot, it will sort of go through your entire code base here. So the function that I have either sort of in this code folder here or sort of in my legacy code, and sort of make a list of all the sort of styling issues that exist. And as you can see, there are a lot of problems with them. And for each of them, mishit will sort of tell you where the error is happening. So here, you know, like group level and legacy and code and group level and line 322, and it's telling us that the line does not have a semicolon at the end. Here it's telling us that in the same file, but line actually on the same line, there is some spaces, some indentation that's not the proper one. So it's giving us a whole list of things that we should reformat to make sure that the code that we have complies with the rules that mishit sort of tries to follow. Obviously, when you see that you have more than 1,600 issues to fix, you start to lose hope, because fixing those manually is going to be a bit of an issue. But actually, mishit comes with a way to automatically fix at least, if not all, but at least many issues. So let's first run this. And actually, it's the argument --fix, which will try to automatically fix most of the issues. So I think it should mention that some of them have been fixed, for example, here. So if we run it again, we see that we've gone from more than 1,000 issues to only quote unquote 100 issues. So our code now should look quite different from what it was before. If you want to see what the code looked before and after, you could use git diff to sort of show you some of that code. We could take some of the very simple function that we have, the sort of the multiply number function that we created, and it would show us that what it's done is that it has added some spaces after the commas. It has indented the code properly here, and it has added semicolons at the end of each line. So this is for a simple function. Now, if you take a more complicated function, like in the legacy code, what is it? I don't remember, group level, you can see that now there's going to be a lot more changes applied here. So now we see that all those things have been indented, and that some of the code, some of the lines have now like semicolons at the end. So when you have a lot of changes fixed all at once, looking at the difference between the before and after is a bit overwhelming. But it's this is definitely a time saver. But as you may realize, what we've done already is we've actually now changed the code. So it would be a good thing in general to sort of run your test even when you sort of reformat it, just to make sure that the code has not been sort of, the behavior of the code itself has not been reformatted. So even before you sort of, even after running a reformatter, a tool to format your code like this, is usually a good thing to still have all your tests in place to make sure that your code still runs as expected. So this is one of the first tool that we can show you, the sort of the styling and reformatting aspects of Misfit. And so now we've fixed all the errors, all the style errors. So now we can actually make a commit to sort of make sort of a new checkpoint sort of in the history of our code. So git add all. So now we can check that all our files are staged. Yes, they are all staged. So now we can make commits. Run Misfit linter style with, well, yeah, actually, let's fix issues with Misfit. That will be another way to say it. So now we have a new commit. Now let's move on to sort of the next tool that comes with Misfit, and is the mhlint, which is a linter which will find some potential bugs that you have in your code. So let's run this, and it's telling us that we have one problem here, for example, is that in the function group level, the name of the function actually does not match the name of the file name. So this is one thing with MATLAB that you may have seen before, is that if you write a function, where is it? It's going to be in legacy in code. If you write a function here, the file name is group level.m. Then in this case, it means that the main function, the top level function, should also be called group level. And you can see that MATLAB sort of itself complains about it and sends you a warning, which you can actually also fix here by applying the suggestion that MATLAB could do. So here we go. That would be an easy one. The mhlint could sort of flags other errors, but here it's only showing you one. So if we run it again now, it's going to go, hey, everything is fine. So that would be sort of an easy fix as well, but you may that may help you sort of find other potential bugs in your code. So that would be that next thing. So find all LinkedIn errors and commits. So we're gonna make a commit again. So get tips and all, and then get commit. Fix LinkedIn issues. Ideally with the proper spelling like this. Good. And now I'm going to show you how you sort of can start configuring mishit. So the idea of what we're going to do here is get to a point where whatever tool we run with mishit, we don't get any errors. And I'm going to, the reason why we're going to do this is that we're going to go to a situation where all the errors that mishit will sort of usually detect are silenced. Let's say that some of the lines are going to be too long for mishit. So we're going to silence that error, or some of the way some functions are named is not the correct one according to mishit. We're going to silence all those errors at first. And then what we can do is sort of change sort of the behavior of mishit to only detect certain errors and sort of flag and send an error messages for certain problems in our code, and we can sort of focus on just fixing those type of errors. So let's sort of start doing this. The way we would add the configuration for mishit would be simply to add a mishit.cog for the configuration file. Preferably with the correct spelling for the file, and this mishit.configuration. And if you do not remember how to sort of what goes into the configuration file for mishit, in this case, what I suggest you do is that you go and go to the website of mishit and try to figure out where in the documentation they have information about their configuration. So, which one is it going to be? LinkedIn style checker, for example. For example, we sort of want to make sure that our lines are not too long, or that we sort of want to figure out if we get a lot of errors because of that. So the way you would start off doing this is that you're going to sort of change the you're going to sort of be running, for example, in this case, mishit style to sort of minimize, reduce the number of errors you get, right? So here, for example, we're still getting errors for line length. So let's sort of just increase that until we get to values where there are no more errors related to line length. Okay, so we still get some errors. Let's go to 200. We still get errors with line length. So let's go to 250. Okay. So apparently there are no more errors with line length. So on that front, we are good. So the next thing we have some naming issues and some copyright issues. So let's try to figure out what are the name of those rules. Where is it? One space. So this is usually the name of the error, and redundant brackets is okay. So that's the name of the error, and the way you sort of ignore certain rule is and you just type ignore. Isn't that right? I never remember because I always have to look it up. Ignore. Let's try to see where that works. Oops, we see now we're getting some problems because this is obviously not the way this works. So ignore here, maybe. Nope, that's not the way. So I'm going to do what I usually do when I don't remember how to do this. I go and check into some of my own project to remember how it's supposed to be done. So let's just do that now. I'm going to grab one of my typical projects. It was some code. Let's go to the bits MATLAB one. There should be a misfit configuration in here somewhere. There we go. And obviously there is no ignore rule in this file, so this is not helping us. Good. Let's just try to find another project where I know this is. I have some of that. Nope, that's not going to be here. Nope. Let's see if I have something in this one. Nope, I have a lot of things, but not in this one. Yes, it says suppress where not ignore. There we go. We're making progress slowly. So ignore. I think this value has to be between quotes. So there we go. And now we also have the naming function and the naming script. So let's try to also suppress these rules. And name script. Good. All right, so now we've silenced most errors. So then we'll be able to sort of start addressing some of those issues one by one. Before we move on, though, I wanted to see, was that all the things I had to do? Adapt line length, adapt copyright. Yes, that is correct. Good. So, for example, what I would do right now is I sort of add this configuration, then commit it, and yes, it's very big. Okay, so that would be the first thing I would do. Make sure that we start with a situation where you have a basic configuration that sort of silences all the errors. And then what I would start doing, for example, is that I would start to sort of, let's reduce the line length that we allow in our code, and let's see what mishit has to say about this. So you run mishit, and now it tells you that we have two errors. Both in the analyze.n file, so let's go and see in there. And then I would sort of start focusing on those issues and sort of fix those problems first. So we have line 11, sorry. So where is it? Yes, there it is. And that's the one. So we can see that this one is due because the fact that we have a very long comment here. So let's maybe just take this one and move it above. Oops, here. That still is going to be, I suspect, a bit too long. So let's try to move things around. I'm doing it in VS Code, but we could obviously equally do it in MATLAB. So for example, we could just do it like this. So there we go. I tend to prefer to do it in VS Code because then you sort of can just have your code right away and right in front of you, and then you run sort of mishit in front of you. So now we have 5 styling issues. Oh, because now we have some training white spaces. So the best way to do that is to just rerun with mishits time with fix, so that it will automatically fix any issues we have. And we run it again, and we have only one issue left, which is line 1208. 208, and it's this one. Okay. Well, possibly rewrite this and this maybe, where we ask it to just start in like this. Is that going to fix things? Yep. So that is definitely one way to make your line shorter. So this is, for example, how you would start addressing your problems one by one. To just sort of start lowering, or sort of like putting a higher, like changing the threshold where mishit is going to complain about things. So we could sort of like link to it now to 180 and run it again, and then we can sort of address those issues one after the other. For example, now we have some issue in code with level 12. So let's just go there. Line 12. That's a very sort of long comment that we can sort of start sort of rewrite in a way that's a bit more, easier to read. For example, something like this. And then let's. So now we have same line is going to create some more problems. 205. Let's try to address this issue the same way we did with the previous one, and so on. So now you can sort of slowly start sort of cleaning up your code by sort of changing some of those rules that standing rules that mishit follows, and fixing them one after the other. So this, and then obviously every time you sort of make those changes, because now you are changing your code, make sure that you run your tests. So you make sure that the code still behaves as expected, and then sort of make commits. So in this case, you can add all and git commits and sort of fix line length, and there we go. And then progressively, you can sort of change the way things are. So how your code is formatted, and this allows you to sort of focus on one problem at a time rather than trying to address all the formatting issues all at once. Sort of a divide and conquer strategy to help you clean up your code. Okay, so this is how you would use mishit in practice, and this is how I think to use it. So hopefully that will sort of help you sort of progressively get to a point where you can sort of clean up your code bit by bit.
All right. Okay, so next section is on refactoring. And just before you all fall asleep, because we are all digesting, I have a few questions for you. Okay, who has copy-pasted code, either from Stack Overflow or their own code? Yes, we all do this. Okay, who here has written a MATLAB script? Okay, good, awesome. Just in case, who here has written a MATLAB function? Good, you're doing better than me just 10 years ago. Awesome, you're great. Who has scripts or functions that are more than 500 lines long? Who has scripts or functions that are more than 1,000 lines long? Yes, we all do this. Ideally, this is the whole point of the workshop, is also to avoid getting into that situation. Who has old code they do not understand? Yeah, right? So ideally, this is also the point, so that you have code that's more readable, so that when you get back to it 2 months, 6 months later, you go like, oh yeah, I know what this does because it's really obvious. At some point, there should be an image here if loading wants to happen. There we go. That's not, yeah, okay, cool. So a bit more on technical debts. This is another PhD comic image this is obviously a fiction, but like where you end up having a whole bunch of files that have very, very similar file names. The funny point about this one is that just by reading the file names, you tell the whole story about, you know, the experiment doesn't work, you recalibrate, and then eventually things work, and you have just used this one, and then you have a meeting with your Professor Smith, and then you start over. Very funny. Let me show you some of my old code. So this is on GitHub. This is the code from which the file I was telling you is coming from. I've made a checkpoint, sort of a tag called the mess, because let me show you how things look like here. Okay, little trick. When you're on GitHub, if you press the dot button, it will open a VS Code in your browser, so you can browse things a bit more easily in here. Just needs to load a little bit. But I want to show you how things got really out of hand on that project, and things that I wish I would had never done that I would have never done if I knew better. Come on, it's just a bit slow, but eventually we'll get there. No. Actually, you can do that on any repository on GitHub, so that if you want to browse the content of that repository in a easier fashion, it will sort of load like this, please. Okay. While it's doing its thing, I will tell you what it's supposed to show. So what I did for this experiment was an fMRI experiment, and we tried a whole bunch of different analysis pipeline because we wanted to sort of clean the data in different ways and try different models. Oh, there we go. Cool. So where is it? Is it here? Yes. All right. Cool. This is the thing I wanted to show you. All of this folder contains a slightly different analysis of the same data. And all of those folders contain almost exactly the same files. The names are almost exactly the same. You would have to sort of look very, very closely for each file to know what was the difference between each of those. The way I did that was literally copy-pasting one folder, changing a couple of lines, and then running this. This is a madman's way to organize your code. Don't do this, and hopefully by showing you what I'm showing you to do, you will not get into this situation. At least each of the folder was sort of telling you what each of analysis was, but yeah. I'm also once again showing you to tell you we all have horrible code, but sometimes you don't know better, so there are better things, there are better ways to organize yourself than, you know, to not get into that situation. Cool. All right, so I've been throwing that word a little bit here and there. So refactoring means just this. So meaning that when you refactor your code, you're going to change the code, but not the behavior of the code. Meaning remember the input to output relationship, that's going to stay constant, and you can completely restructure the code in the middle, but you keep that fixed. And how do you know this thing is fixed? Because you have tests to tell you that those things, when I give you this input, you always give me this output. Now you're free to just go nuts on your code and change it and rewrite it and make it much more readable, because you have kept this relationship between your input and your output constant. Okay, one of the first things that we do is copy-paste code, right? Which leads to duplication of code. There is this principle or this sort of acronym that you might hear in software engineering called the DRY principle, which stands for don't repeat yourself. It's usually opposed as the wet code, which is either we enjoy typing or we sort of write everything twice, right? So the DRY principle tries to say, okay, avoid to sort of duplicate things and avoid sort of copy-pasting things. I usually tend to say that copy-pasta leads to spaghetti code. Spaghetti code is another word to say code that's really hard to maintain or to work with. That's really what happens here, right? Let's say you have 3 functions and this bit of code is repeated. You've copy-pasted this from here to there to there. Now let's say that you find a bug into one of those sections. Now you have to modify it in 3 places. If you've copy-pasted it 50 times, now you have to change it 50 times. Kind of annoying. So what you can do is do a refactoring by extracting this code and putting it in a separate function. Now you only have one sample of that code to modify, and it will apply it everywhere else. So that's usually one of the things that, that's like the basic thing that you will have to do a lot, is just extracting functions, creating functions, so you don't have to copy-paste things. Another thing that you're going to hear people say is that when you create function, they should try to follow what's called the single responsibility principle, meaning that a function should do one thing, should only ever do one thing, but do it really well. So sometimes people have this sort of rule of thumb to say, okay, to make sure that your function does not do too many things, make sure that your function is not longer than one screen height, right? So that you don't have to scroll to see the whole body of the function. Okay, problem is that this is kind of a bad rule of thumb, because someone is going to flip their screen around and tell you, hey, my function is just one screen height. What are you complaining about? So, okay, so more seriously, actually, this comes from, so Martin Fowler is a guy who literally called a book called Refactoring, and he's got a whole catalog of refactoring that you can use on your code, like a recipe book pretty much. And that comes from his blog post where he was saying, okay, here are how many lines of code are in the different function he has, and this is sort of the cumulative, how many, these are the number of functions or methods in this case, a bit similar, that he has in one of his code base. And you see that pretty much, let's say that 90% of all the functions are less than 10 lines long, right? So it's fairly normal to write a lot of functions that are very, very, very short. This is also just to make sure that each of your function does one thing, and it also makes it easier to test, because then your tests are much easier to organize, because you don't have to test for a million things. Okay, another thing that you're going to need to do a lot of refactoring around are comments. 90% of all comments are pretty much like this, right? Stating the obvious. I mean, I have code like this. I have comments like this. I mean, to the point that I got a bit bored during the lockdown, so I got a labeler, and I got to the point of just starting labeling thing in my apartment the way I would comment my code. So I have a cup that says cup. I have a fork that says fork. Okay, you can see what's written on the microwave, but it really resembles some of the comments you're going to see on some of the code. Hey, don't judge me. We all got bored during lockdown, so we had to sort of entertain ourselves in some ways. Okay, so rule with comments is it's only for things that you cannot express in code. So if at any time you can sort of write the code in a way that's clear, so you don't need the comment, just do that. If you just have comments that say exactly what the code right below is doing, delete the comment, not useful. And if the comment says what the code could say, rewrite the code so that you make the comment redundant, and then delete the comment. Another thing, yeah, sorry.
I mean, sometimes you comment for structuring the code, right? In terms of this piece is doing this piece is doing the figures.
Yes, when you start using code like this, usually it means create a function where the name of the function. Let's say you say, okay, you say below I'm going to sort of making figures for reaction times. Create a function that's literally called make reaction time figure, and all the stuff that was below, put it in a separate function. So now in your code you don't have a comment, you literally have a function that says exactly the same things, but most of your code, like your main function where all the things was happening, is becoming shorter, but it has just subtitles that are actually code itself. Does it make sense? Okay. That's usually the way people say, it makes that's how I've organized most of my code at the beginning, and I was like, oh no, I'm just going to create functions. Function names can get pretty insane, right? But at least, it's code and it's not a comment. Yep.
Please let me ask you a really dumb question, but what are common things that cannot be expressed in code?
Sorry?
What would you say are common things that cannot be expressed in code?
Comments are things that cannot be expressed in code. So it can be, for example, So sometimes you have the documentation of the whole function, meaning, can I open just pretty much, okay, I have SPM here for those who do fMRI, but let's open the main function from SPM. All of this technically is, all the help section, for example, is technically comments, right? And you cannot really express that in code, right? So it's sort of explaining the overall purpose of that function and describing all the sort of inputs and outputs is definitely something that you would not be able to express in codes, right? What are some other obvious examples? I'm trying to think of some obvious ones but that's the thing, is like when you start thinking about it, there's a lot of things you can just express in codes without comments. So eventually it leads to having way less comments in your code, and then re-expressing all of that with just code. Do I have any examples? I'm sure we're going to encounter some where eventually it would be good. So like sometimes giving additional context of why things are being run this way. So for example, sometimes you might have code that might seem not obvious. It's like, meaning people have written things this way, and you might say why, and then the comment could be, things are written this way because then the code is faster, is optimized, and things like this. So it's just try to answer questions that the person might have reading this, but that are not obvious to write in code itself. So it's something, at the beginning you might be confused, and it definitely takes practice to figure it out, but eventually sometimes you go like, oh, I don't need a comment for that, I can turn it into code. There's no way to express that in code, let's make that a comment. Yes?
Not quite sure if that's an example or that style that I'm having, but if I'm going, for example, to have an experiment with different stages, like that's the training block, that's condition 1, condition 2, I like to encode it just as, it's trial phase 1, 2, 3, 4, and afterwards I write in comment what the 1 stands for. So I later have something to look it up. I'm not quite sure if it would be more correct to have this all as string and later decode it.
So actually, I have an example in here that we can look at later. So it kind of makes sense that you have like a number to represent the phase of your experiment and things like this. When you come back 6 months later, if you don't have, if it's not written in a comment what this number stands for, you will not remember it. So usually I tend to say, if you can have it as a string, rather than a number, it will be easier to read later on. Also, another reason for that is that, I think I have it, let me give you an example. Where is it? Oh yeah, I think it's at the very top here. For example, congruent trials is 1. Here. 0 is a congruent trial, 1 is incongruent. So when we talk about trial type now, every time you have to keep this information in your head. So like when you read code, you're starting to load your working memory as a human being. So anytime you can make it easier so that people don't have to remember, oh yes, the 1 means that, and it's really obvious when you just read the code, it makes reading your code easier. So actually, when I was reading this code to prepare for this, I was like, oh, I would probably now rewrite this as just not having numbers for the condition, but I can literally have a string that says, this is this, and this is this. Obviously, it will depend on the length of your function. If the function is 10 lines long, 1 and 0, okay, it's, you can sort of remember it for 10 lines. Here we have like 400 lines of code. Maybe easier if you don't have to sort of remember what was written 200 lines above, right? Does that make sense? Yeah, it's
easier to deal with numbers than strings.
Yes, well, especially in MATLAB in general, it's really more oriented for this. But it's the other thing you could do is you can also create a function that takes care of like, every time you have this string, you convert it to that number, right? You can, you could have, function trial type, I don't know, trial type, and if you give it a string, if you give it, I don't know, string, it will sort of return a number, and you can sort of create a matching of like, oh, if this is this, switch string. If you have case, I don't know, ink, then the value you return is 1, and so on, right? And then you return this. So this way you can create a small function that takes care of the mapping to just deal with numbers. But you sort of like, when you read the code, you just read the sort of the string, right? So there are ways you can create small function like this to still sort of make sure you only deal with numbers, but then when reading the code, you go like, oh, yeah, that's fine. It's easier to understand. It's like, it's a bit of trade-off. It will depend on what is more useful for you. But definitely, it'll be one of those cases where like, maybe just try to make it more easier to remember. Also, easier on reading at least. Cool. Thank you. Okay, so who has code that sort of like start looking like this, where you have just like for loops within a for loop with like 3 if statements? Yes, I do. We all have this. So technically, yes, try to stay away from this, because once again, trying to work the logic of this is going to be such a drain on your working memory. It's very hard to make sure you don't have a bug. There are plenty of techniques you can use to sort of reduce the number of nesting. The main and obvious one would be, for example, take this for loop here and sort of extract it into a separate function, so that you're sort of reducing the number of nesting. Usually, the main thing is like try to create sub-function for each of those. It really makes it easier to read in the end. And also then, now you have an independent function that you can create a small test for, so it's easier to once again make sure that it does what you think it does. You're gonna be so sick of hearing me say the word test by the end of this. I'm sorry, I'm not. Okay, so that's the next section. We're going to be talking a bit about automation. But first, I actually want to sort of show you a couple of examples of how I would sort of refactor first. Okay, sometimes you're going to hear people talk about coders, software developers talk about code smells. Like a smell is usually a negative thing. It's like code that starts smelling is code like you actually want to change it because it starts looking ugly. You know that if you had to work with this code, you would actually write it differently. So commented code or dead code, that's one of those. That's something I used to do a lot. Like, oh, I just want to check something quickly, so I'm just going to comment this code, and then you leave it commented forever. And then when you come back 6 months later, you go, why is this commented? What was it supposed to do? I don't remember. So pretty much my rule now, if I see commented code, I just delete it. I mean, ideally, if you use Git, you can always get back to it. So if it was really just that necessary, you can always get it back. But that's like, yep, delete. Because it will make, also if you start sharing your code with someone else and they see commented code, it's just really confusing. I was like, am I supposed to be doing something with this? Is that important? It's really just super confusing as to just why it's there and what it was doing and so on. So like, yeah, removing commented code. Let's remove this, fine. Okay, dead code, I think I had it in here. Dead code is code that never gets executed. So that's also, once again, where testing and coverage are useful. So let's say you have run tests and you have coverage and it highlights some subpart of your code that's red and never gets run. And no matter which test you run or which test you write, it will never hit. Like, for example, a very sort of, I would say, obvious example is like if false display, I don't know, something, right? this will never run. Like, because false will always be false, you will never enter this if block, so this will never appear. If you had, I mean, this is obviously a silly example, but sometimes you may have things in your code that will look like this, and you go like, I don't need this, so you can completely delete it. So that would be some things like this where you can, when you identify things that is dead code, you can go like, fine, let's remove it. Okay, so we've changed the code. I mean, it was commented code, so obviously that shouldn't run, that shouldn't affect what the code is running, but in general, it's just like, yeah, let's just run the test, make sure that everything is fine. This can be useful if you remove dead code. I mean, something you thought was dead code, but for some reason it isn't, and now it actually, you get some errors. Okay, maybe I shouldn't have removed this. Nope, wrong window. There. And obviously, git add all, git commit, remove that code, remove that code. All right. Okay, useless comments. Those are some of the things I was mentioning earlier. So, I know I have a few examples in there that are just really, this is a cat. Oh yeah, there are one which, I have one right here. Trial type, what type of trial this is. Wow, super useful. In other news, water is wet. Okay, check response given, maybe we can keep this one. I'm not going to remove all of them, but I have a few others where I was like, oh yeah, I think I had a few here. Oh, saving the data. Really? Wow, I would have never guessed that. Okay, to be fair, when you're starting with a new language, only when you start programming, those comments can be useful. Okay, I'm making fun of myself, but if it was your code, I would go like, depending on your level of programming experience, sometimes at the beginning you're lost with programming and it makes sense to go like, oh, this is what I'm doing here, this is what I'm doing here. So it is fine when you're beginning to just use those comments. As you become better and better, you can go like, yeah, I know what this is doing, then we remove it, it's fine. But like, for example, those like, oh, I'm saving the PDF, I'm saving the figure as a PDF. Okay, I think that now I can sort of, by reading this code, I can sort of understand this. So I can remove some of that. Same for here. So yeah, once again, go through your code. If you see just useless comments, remove them. And then once again, git add all. And can we do that in just one line? Yes, I think we can. Git commit, remove comments. Cool, all right. So express yourself in code rather than comments. Okay, let's try to find an example where we can do this. Yeah, that one is a bit obvious, and it also relates to finding right names for things. That's also one of the hard things in programming. How should I name this function or this variable? We have a variable called n, and it's a figure counter. What can we do to maybe make this, to express this in code that would make the comment redundant? Well, we can do this. If you didn't know MATLAB, once you change a variable, you can just press Shift and Enter, and it will change every time this variable enters. So now we do this, Shift Enter, and remove the comment, right? And because we're never sure of what we do, let's rerun the test to make sure that now we've changed code, things are still running as they should. Apparently we're good. Are there any other, I'm sure you can find plenty, but I'm not going to start refactoring 300 lines of code in front of you because you're going to get bored pretty quickly. I can try to make it entertaining, but hey, maybe not that much. Let's see if I can spot some obvious one I had seen before. Figure counter, nope. Are there any comments that was super obvious that maybe I could, yeah, nothing jumps to me right now. We'll go move on to the next one. Okay, duplication. Okay, that's the part where you extract a function from your code. So things that are duplicated, that might not be obvious, but you can find, when you're on your own code, usually you're pretty good at finding them. On other people's code, maybe not as much. Not here. I want to try to find one that's not too complicated. And one that's kind of useful. I have a few potential targets in here. Yeah, let's go with that one. Where are you? Okay, here, for example, especially because it's a very long line, so let's try to rewrite this. So here, if the trial type is something, we try to identify which stimulus we used. I don't know, apparently this is what this code says. And you can see that pretty much all those lines are exactly the same except for this thing that changes here, right? So we can just create a function here that's going to go usually what I would do is, okay, let's close this function and create another one here. Up. Value. Okay, I'm not going to get very original here, but I could go find which stim, and I think, what was it? It was, what was it movie type? Which one was it? Where is it? Yeah, number of movies, and then we need to pass it all the other stuff as well. Okay, let's try this. So number of movies. What else do you need? You need this guy here, and so this is where we use it. And oopsie. And trial type is here as well. So, okay, find which stim. Usually when you start refactoring code at the beginning, it feels very, very sort of, I wouldn't say useless, but like, why am I doing this? But the thing is that once you start chaining one refactoring after the other, things become definitely easier and sort of shorter to read. So that might not seem like the most useful thing we have done, but if we had to rewrite things later or read it later, it'd be a bit easier. Okay, those three. There. Okay. Can we move those 3 lines? 3 lines. Okay, also because now we're making some of our lines a little bit shorter. So this looks good. At least for now. Wait, if we don't return the value, this is never going to work. Cool. Also, most likely what I would start doing now is start making sure that my lines are not too long. So I would start just adding sort of making things a bit shorter like this. And maybe even just like this. Okay. What do we do once we've changed the code? We run it. Well, now we're good. We're happy we have test. The function which GM was closed with an N, but at least one other function definition was not. What do you mean? Is that a nested function? Oh, it is. Yes, that's better. Yay. Oh, and that's why we write tests. The figure was not created? Oh, we have an I here that was never passed. So maybe that's why we're having issues. So let's add an I here. So that's also why, I mean, sort of, I guess it kind of becomes obvious that if you don't have tests to sort of start doing these things, you are tempted to never do it. Because otherwise things start failing left and right, and then you have no idea where and why and so on, and then you've changed your code and you just give up and never clean your code. So now we've refactored this little function, and once again, let's just git add extract which stim function. Whoopsie. Okay, so this is an example of how you would sort of start getting rid of duplications. Obviously, there's tons more duplication in this thing that you would sort of be able to sort of refactor. I'm not going to show you all of them, but once again, this is an example of how you would do it. Okay, remove some nesting. I have a couple of examples in here. So, okay, the most obvious one is this try catch thing here. So anyone doesn't know what a try catch is, or anyone knows? Maybe I should explain. Yeah, okay, I'm gonna give you a small explanation. So a try catch is a way to make sure that if between the try and the catch you have some error, let's say, okay, so this is code that will work. A equals A1 plus 1, cool. But then we can also write something that's just for sure is not gonna work, or even just more obvious if an error happens in the middle here. Then if we have an error in this section, then the execution will stop. B equals 2 plus 2. The execution will stop at this error, and then only the catch part of the code will happen. So in here, if we have B equals 4 plus 4, let's save that here temporarily. So if you run this, it's showing you A1 plus 1 equals 2, that's fine. You encounter an error, and then it skips the next lines and then moves on to the catch. This is useful if you you expect some part of your code to potentially break and you want to do something in case it fails, right? So that's like a fallback solution. For example, anyone here uses Psych Toolbox as to run experiments. So Psych Toolbox is a toolbox for MATLAB that you can use to run experiments on your computer. Very often, the way Psych Toolbox runs is that it will just display things on the whole screen. And if your script crashes, you're left with just like the experiment on your screen, and you have no way to sort of access MATLAB and just kill it, right? So usually, one advice you have when you work with Psych Toolbox is like put your whole experiment in a try catch, put all of the experiment in the try section, and in the catch go like, close everything, shut down, and give me back my computer, please, right? So this is usually how you would structure things. So here I'm sort of using it because I was afraid that maybe some error would happen. And then if you go at the very bottom, I go like, just stop everything you do, go back one folder up, and last error will just the last error you encounter, just throw it again, right? So here we could also just do last error. If you do this, it will rethrow the sum error from here. It should at least, oh no, catch, well, nope. See, not even in my old code would do what I think it was supposed to do. So this try catch, I can tell you, is completely useless. So you can just completely remove it and just now re-indent your code properly. So now we already have code that's like not as nested as before. So that's already one thing you can do, and you can sort of rerun the test to make sure that everything runs, and you're happy. Okay, cool. So that's one way you can sort of reduce the number of the level of nesting. Another one that I know is in here is this thing. So what I would do for this analysis, I would go through all the trials of my experiment, but I would only run the code, I would only sort of analyze the code where the reaction time, okay, that is something kind of annoying as well, how to express things in code so it's easier to read. Reaction time equals this thing. And now it's a bit more obvious what this if block is about. If reaction times actually also, usually what is usually advised is that if you have things like this, put the unit in the name of the variable, because then it becomes really obvious what you're working with. So here what I would do is I would only analyze trials with reaction time superior to 0.05. But another way to sort of do this and get rid, but okay, what this forces then is that all of that code has to be sort of within this big if block, right? So a way to sort of get rid of this extra indentation is to sort of do it the other way. So you go, if this is inferior or equals to 0.05, you can just skip this trial and continue. And then, which means that all of the thing that's below will not get executed, and then you can move back this thing by one level of indentation. It also makes it a bit easier to sort of read in the end, because you don't have that many levels of indentation, and you go like, oh, I know that I've excluded this, I cannot think about it anymore, my working memory as a human being is happy. And then run your test, and obviously now it fails. This statement is not inside any function. Oh, is that because I started just removing stuff left? Oh, yes, I removed the if block, so now I need to remove the end as well. Check for missing multiplication operator. What is this? Did I just copy paste thing randomly? Oh yeah, it looks, what is this? Where are you? What is this horror? Yeah. I did copy paste things several times, didn't I? You know what? That's also why I love using Git. Yeah, let's just do Git restore legacy code. Good. So now, okay, so now we are back to where we were before I started doing horrible things like this. And we can remove the try catch again. That's one. Okay, if that doesn't work, I'm like, okay, that works, cool. And while this is running, yada, yada, yada. Let's try that again. Where did you go? Also, that's another reason why it's kind of nice to have smaller functions, that you don't need to scroll as much. And it disappeared. There we go. Okay. So let's do that again. This is reaction time in seconds. If reaction time is inferior or equal, we continue. And but that also means we need to remove, no. That's the one we're supposed to remove. Yep. Yep, okay, now it works. Good. And once again, we remove nesting. Yep. Cool, so we're good. So this is one way where you can remove nesting as well. Yep, that's one of those things I wanted to show you. Oh, magic numbers. I think we all do this as well. So what we usually call a magic number is, you can also sometimes refer to as a hard-coded value. Well, we have used one just here. We have a threshold for inclusion or exclusion of our trials, right? But now it's lost in the middle of the code, right? So what you can do, what I would usually advise is like, put at the very top of your code the stuff that you're actually gonna sort of, and this is also gonna be a constant. So usually constant, you can usually use capital uppercase letters to sort of signify that this value should not change. And then you sort of, where is it? There. So this is usually how you get rid of either what's called like hard-coded value or magic numbers. What I would even now tend to do is I would pass what I would call a configuration structure to my function, and here go configuration. So reaction time threshold, and we say 0.5. You pass this to your function, and from here you can just, I would just grab it like this. Why it's kind of interesting to do this, it becomes much easier to then change the behavior of your function like this. Yes, sorry.
Shouldn't you write the reaction time threshold below the clear all?
Exactly. Okay, that's also something that I used to do a lot. I would write function at a clear all, and then I was like, why doesn't it work? My variable is just here. So yeah, definitely those, actually even the 3 lines, the CLC to clear the what's on the screen, the clear on the close law, they don't belong in a function. Clearly you want to remove those, because otherwise you get into weird things like this. It's funny, I think a couple of years back one of my lab mates was like, but look, I declared a variable here, and like 10 lines later it's not recognized in the function or in the script. And I was like, yeah, you have a clear all somewhere, that must be messing with it. And now it works. Yeah, thanks. Yep.
What's the rule for putting functions into the script or outside, just if you want to use them in some other script?
So usually what I would do is that here, what I'm doing, all of the stuff I'm putting in here, I'm adding them at the bottom as local functions. You could do it in a script as well, where you have like your main script and then a bunch of helper function as well. It's completely fine. I do this until I realize I'm going to need the function somewhere else, and then I move it out, right? But unless I get into the situation, I keep them local because it's a bit easier to read, like everything is in one place together, right? That's the rule I follow. You organize your work as you want, right? Definitely, but that's usually the sort of the algorithm I tend to follow to organize things. Cool. So magic number. Oh yeah, I'm putting this here because the other day I think I had a colleague who was like, "Can you help me or like give me tips on how to clean my code?" I was like, "Yeah, no problem." Half of the code was in Croatian. I was like, I wish I could help. And I'm okay with learning languages, but I was talking about computing languages, not human languages. So it's like definitely in general, try to use comments in English and code variable names and function names in English, because it will definitely make it easier in general for people to understand your code and reuse it. And also, unless you are in a very short loop of like 3 lines or 5 lines, avoid using just I, L, M, and N. Just try to give your variable like just names that are a bit longer and very explicit, because otherwise it gets very confusing. Yeah, one kind of a code smell, as I was saying earlier, is like if you have very, very long functions, try to sort of make them shorter and shorter and shorter. And obviously one way to do this is extracting a function. I think I wanted to sort of show you how that you can do this even to create figures. Where was it? Yep, so here, for example, I have just a bit of code to create a reaction time figure. You can totally just sort of move that into something as its own figure. So you go function, reaction time figure. Also, the good thing about this is you can create, you guessed it, a small test for that function, so you can sort of quickly work on improving how this figure looks like. Okay, figure counter gets incremented here, so we will need to return this. What else do we need? I think we only need total trials, yes. Yes, that's the only thing we need. And then I think we have our function to create. And then what we can do is sort of maybe indent this a little bit. Okay, something I also like to do is, in MATLAB, things sometimes you have like the name of a parameter and then the value. And I tend to try to sort of split them line by line like this, because then it's super clear how they go together, right? And yep. And now we can just reuse that thing over there. Where are you? Okay, and now we've also removed some code that was a bit sort of superfluous. Cool, does it still run? Of course it doesn't, because I'm missing, what am I missing? Invalid expression for missing multiplication operator. Why am I copying and pasting things in the middle of nowhere? Nope. What did I do? How did I get here? Sometimes copy pasting are just not your friends. There. Cool. So now hopefully, hey, okay. So yeah, extracting figures is definitely one thing I would do. So have like a little function to make each of your figures, so then you can sort of just work on each of them independently. Definitely something I would advise to sort of do, because it becomes easier to just sort of just see that code and go like, oh yeah, okay, you plot just this is how you label it, fine, fair enough, I understand. Okay, so usually, okay, this is all fine, but sometimes you don't even know where to start. Yeah, let's say you have like 5,000 lines of code. Where do I start refactoring stuff? And this is usually where mishit can also be used. there is a part of mishit called metric, where it will give you a whole bunch of statistics on your code. So I think if we just run mh metric, so where are you? So yeah, I think you have a summary at the end. So number of lines per file, and it sort of orders them by like the biggest. So obviously, maybe you want to focus first on analyze because it's got 408 lines of code. Nesting, that's one of the things I was mentioning. This will tell you how much nesting you have in some of your functions. And you can start focusing maybe the one that are the most nested. Okay, I have not talked about cyclomatic complexity, but that's pretty much, if you have a lot of if statement and nested if statements, then your code becomes more and more complex. And you can see that analyze has a complexity of like 43, so you definitely, usually we tend to say, start getting worried if your value is above 10. If it's above 15, you should definitely just start working to clean that up. So here we're clearly over the threshold. Number of lines per function, that's also some sort of metric you can have. Number of paths is sort of related to sort of the cyclomatic complexity, and it's like how many possible ways can I go through my code if I follow the logic, right? And here we have, what is it? Yeah, just 160 millions. Cool. So definitely keeping functions short will definitely avoid things getting out of hand. And that's the number of parameters you have in the function call. So here, now the biggest function we have is like the find which stim that has like 6 parameters, which is actually a bit much. And you can set things up in the mishit configuration so that it's going to start warning you if things get out of hand. And now that's where I need to check. That's where I need to check. Not the diff. Where is it? Copyright configuration files. Applying. Where is it? Global style configuration. You know what? Complexity. Is it? Are you anywhere here? Nope. Complex projects, nope. Oh yeah, for no line length, I think I've already put it somewhere. Obviously, it's not easy to find in the documentation, so what I do in that case is that I open another of my projects to figure out how the heck I did it over there. So, give me 2 seconds, I will be right back. Let's close this, yeah. Just close everything. Where is my configuration? Here. Where are you? There we go. So let's copy all of those guys and reuse them here. So maximum number of line per file 715. Level of nesting, I think we were still good using just 4. Cyclomatic complexity, I think if we go 20 here, it's going to go a bit not happy. And then the way you sort of have mishit just warn you about this is that you, instead of just running mh metric like this, you add the CI flag and it will tell you, hey, you have files that are too complex. So at the moment we don't want mishit to complain, so we're going to do the little trick we had before, which is let's set the cyclomatic complexity to 44. So at least we're sure we're not going to get higher than this, and this should be fine. But at least now we can also apply the same strategy as before. You can sort of start lowering those threshold and tackle one file after the other to make it easier and easier to to make it simpler and simpler. And now we can just update mishit config. Okay. So. And I think, yeah, that's pretty much what I wanted to show you about. No, wait, I'm not on refactoring. Yes, that's what I wanted to show you with how to sort of figure out where to focus your attention first, right? So, I mean, it's also up to you. Sometimes you might not want to tackle the most complex and the crazy part of your code, but maybe some things that are a bit easier. But at least mishit can tell you, hey, this is where you're going to have problems if you don't sort of start working on it now. Yep. Are there any questions? No. Any of you wants to try any of that on your code at the moment? I mean, we're going to take a bit of a break because I think everyone needs it. But if at some point you want to try stuff on your code and like talk to me on how to do it, I'm happy to help. Yep.
I have a question. Do we definitely need Visual Studios to
No.
execute those
No.
mishit functions, or could you
No, you could, all of the mishits, if you have installed, so here I'm in my regular terminal. Nope, I want to go into the MATLAB folder. What is it? You're going to need to execute them from a command line. But you can definitely run it from here, metric CI, so it runs fine here. That's no problem. Why I do it in Visual Studio Code is that I can have my code and a terminal in the same environment. And also because in the next step, we're going to be starting editing most likely YAML files, and you do not want to edit YAML files in MATLAB file editor for sure. So definitely you need some like proper code editor for some other things. But you could run it in any terminal as long as mishit has been installed. If you are on Windows, I think someone else earlier was running Windows, just open if you've installed Miniconda, open the Anaconda prompt, and you can run things from there. Does that make sense? Okay. Cool. All right, maybe let's take a small break. Okay, so I'm going to show you, so ideally what I wanted to tell you when it comes to automating things were pre-commit, which is a type of automation you can run locally on your computer, and try to tell you about how to run things automatically using continuous integration with GitHub. That second part, I'm pretty sure I won't have time. I can show you like some hints on how to get started, but I think, Julia, you said that we have more stuff on continuous integration in another workshop, so I think that I won't go in depth here. So I'm mostly going to focus on pre-commit, which is a Python package that, once again, you can just install by doing pip install pre-commit. I have already installed it, so it should tell me everything is already there. And it's another package that you need that works with a configuration file that you need to say, hey, this is what I want you to do. I'm going to be grabbing one that I had from another repository, and I'm going to explain to you what's in there. So this is a .yaml file. So this is another type of file you may have to work with. I think if you use R Markdown, for example, you may be familiar with them because usually the the few lines at the top of your R Markdown file are like a YAML header, and it has this very specific format where you have to respect a certain number of indentation and things like this. So this is a YAML file. And the way the pre-commit configuration file looks like is that you have a list of repos or repository with their URL, the version you want to use, and a list of what are called hooks, which are pretty much rules that you want to apply automatically to your code, right? So the pre-commit package itself comes up has a list of rules that you can use for your code. If you want to know more, you can just usually click on the URL to just go and see
a description of what all those hooks actually do. I'm going to give you kind of a quick explanation. So this one will remove any white space at the end of your lines of code. This one will make sure that you have just the right number of lines at the end of each of your file. This one will make sure that any YAML file that you have in your repository is actually well formatted. The same with any kind of JSON files. This one will make sure that you're not going to save gigantic files. You're not going to commit gigantic files into your repository, because that's not what Git is for. Git is for text, not for data. It will detect automatically if you have sort of case conflict, meaning that you have the same file that are just different by just the case in the file name, I think. Merge conflicts, if you have any Git merge conflict in any of your file, it will be like, oops, I'm not going to let you commit this. So these are some of the examples of things it can do. I think I'm just going to start with those, and then I'm going to show you how you can also use it with mishit, right? So how it would work, okay, at this point I don't have any uncommitted file. Oh, yes, I do. I have one. Oh no, I deleted one file as well. So these are also the rules that you want pre-commit to apply on your codes regularly. And the way you sort of install those rules is by literally, say, running pre-commit install in the command line, and pre-commit will go and install those into the .git hooks folder in pre-commits, and this is a folder used by Git to automate things, right? Meaning that every time you're going to commit something, Git will go and look into this folder and go like, oh, there's this whole bunch of things I should do every time I commit. So now you sort of another reason why you should commit regularly is that every time you commit, pre-commit will sort of ensure that all those things are applied every time. So another thing that's recommended when you run pre-commit the first time is that you apply those rules to all your files in your repository. So you do pre-commit, run -A for all, and then it will go through all your files and apply those rules you have specified into your entire repository. So this is what it looks like. You go like, okay, first rule is like remove any trailing white space. This failed, meaning that it did find some trailing white spaces in some files. What's cool about pre-commit, it will automatically try to fix as many things as possible. So here it's removing all trailing white spaces from those files. It's here, it would be fixing the end of files for all of those. It didn't find any YAML file, it didn't find any JSON files, and those other ones are fine. So because everything got fixed, if you run it again, everything is green. So now you're good, you've applied those changes to all your files, and you can sort of do git add all and do git commit -m, apply the pre-commit to everything, to all the files. I realized that I've made a commit and pre-commit once again rerun everything. So now every time I'm going to commit things, pre-commit will make sure that all the rules in terms of formatting that I've decided to apply to my code will be there. So it's another thing like you sort of taking advantage that you're going to make regular commits to automate things, but you don't have to run them manually. Everything is being automated. So the good thing with pre-commit is that go and look on the pre-commit website. It has rules to apply to pretty much all languages. Python, it has R, it has Java, JavaScript. It has like a whole bunch of things that will help you automate and just make sure that all your code and all your repositories are clean all the time, including mishit, for example. So here are sort of how you would write the rules to apply mishit to your code. So I'm just going to uncomment those for now. Never remember whether I need to reinstall stuff, but just in case, pre-commit, install, apply.
And so remember that we started refactoring our code and changing a whole bunch of things. But we completely forgot to sort of apply misfit every time. So now our code is like dirty again, so we need to reformat. Yes, question?
So this pre-commit will work in other, like, so like in a spider or anaconda?
Yeah, you will have to run it from the command line. So you will have to open an, like what we were doing earlier with you, like you would have to open an anaconda prompt. Actually, I'm not even sure. I think that it will work. You will need to install the hooks by, you open a terminal and you do pre-commit install. But then, every time you commit your code using whatever you use to commit, it should be able to run that automatically. So you just need to sort of do the pre-commit install once, and then every time you sort of commit code, it will run those things automatically. So I think you should be fine with, like, even if you just work with Spider to run your code, as soon as you commit, you should be good.
Cool.
But here in this case, we've just like changed so that change our a pre-commit configuration so that it also includes stuff for mishit style, metric, and linting. So we can sort of do the same and rerun pre-commit on all the files. And now mishit is complaining that we have a whole bunch of problems, but they apparently should be fixed for most of them. So let's rerun pre-commit on everything. Oops, no, we still have some issues here. So some lines are too long. So analyze 162. So maybe we can fix that right away so we don't have that problem in the future. Where are you? 162 here. Whoa, where did you go? Let's see if that works. Let's rerun that. Yep, everything is clean, so now we can just like pre-commit, apply pre-commit dash mishit to all files. Oh, yes, sorry, I need to add my data. Sometimes you actually do get some useful errors, where it's just telling you just add your pre-commit configuration and rerun this, and you're good. So now you're sort of ready to that every time you're going to refactor your code and change things, the reformatting will also happen every time you commit stuff, right? So now you have your refactoring and reformatting happening, everything at the same time, and you can make sure that you have like clean code. You're only committing clean refactored code every time. So it is 3 o'clock. This is the theoretical time at which we're supposed to stop. I think I've shown you all of that. I could sort of give you I could either give you maybe a couple of, a quick, sort of very quick demo on how you can start using GitHub continuous integration. Or if you want, maybe a couple of tips on how to structure your code.
That would be interesting.
Sorry?
That would be interesting.
Well, that's what I tried to show yesterday, and it failed miserably because I had a bug in what I was trying to show, but hopefully it's fixed today. So,
are we supposed to be...
Sorry?
So we're supposed to be here till 15:30, or?
I think it was 3 o'clock, right? Yeah, it was 3 o'clock. So I'm just going to show you quickly, hopefully this will work, what I was trying to show you yesterday. So what I've done, what I'm working on as well, is trying to create a template repository on how to structure your code that has a lot of the tips I was telling you today already in there. So it already has your mishit configuration, it already has your pre-commit configuration, you have the source folder for your repository, a test folder for your repository. It has some GitHub stuff to actually run your test automatically. So there's a whole bunch of stuff that already exists. And this is not a regular repository on GitHub. It's literally a template repository. So instead of having the big green button being there for just code, it's called use this template.
and here you can go create a new repository, and with sort of like, usually you would create a fork of a repository. Here it's just make a copy of it that's completely unrelated to where it came from. So you can just go like new analysis, and you can sort of start working with this just from like scratch. So this is one way I can like. I was kind of tired of always recreating this configuration file for myself. So like I'm going to create a repository, a template repository I can reuse. Maybe you can sort of do the same and either reuse that or create your own template. If you want to know how to create a template repository in GitHub, it's pretty easy. You create a repository as you would otherwise. You go into settings, and there is a button here that says template repository. And actually on the fork, it would say forked from, and here it says generated from. So it still sort of tracks where this came from, but this is not like a typical fork. So yeah, if you go back into settings here, you can see that here it shows template repository, right? So if you want to create your own template because you know you're going to always be reusing the same structure, you can do this, or you can have that within your own lab if you want to make sure that all of you start with the same sort of standards. This is definitely something you can do. Okay, this is kind of nice, but it will come with a whole bunch of things that can be a bit annoying that you will have to change. For example, I think that, yeah, for example, the copyright entity here is like all the functions in there have my name in there. Not super useful. You're going to have to go and change your my name to your name in all the functions. Not ideal. So what I was trying to do is try to use scroll. There's another package in the Python world called cookie cutter, and let's try to see if this time it's going to work. Documents, MATLAB, cool. I'm pretty sure that it should already be installed, but just in case, pip install. Oops, cookie cutter. This. And then it's just a matter of calling cookie cutter and sort of the URL to sort of a cookie cutter template. So I'm going to copy this. Can I try to make this? Okay, I'm going to try to make this slightly bigger so you can actually see what I'm doing. All right, so that should be big enough. So I'm just going to copy this, and the way it's going to, okay, I've downloaded it yesterday. I've used that yesterday, so I'm like, are you sure you want to do this again? I'm like, yes, I'm sure. So the difference to using just a typical template is it's gonna ask me a couple of questions, and it's gonna adapt the content of the template to those questions. So like instead of like my name, it could be, I don't know. I'm not going to be very original here. It's going to be John Smith. You can adapt your email address to, I don't know, whatever your email address is at foo.bar. I don't care. Username, you would adapt to whatever your username is. What is the name of your project? Oops, my new project. You can add a short description to sort of your project as well. Version, you're starting from 0. Which type of license you want? I don't know, let's go with the BSD license. And there you should have a new project that was created where everything is in there. Let's open it in Code Studio, so in VS Code, so we can sort of navigate. So now things should have been adapted so that like your copyright has your name, and all the MATLAB functions should have the proper name on top of it and things like this. So this is like another way you can sort of start structuring your analysis and your whole sort of project like this from scratch when you're starting a new project. If you have already existing project, you can sort of use the template and then move all your code in there and start reusing sort of that structure if you want, for example. So that would be one of my advice on how to structure things in general for you. If you don't use that template, create your own.
it's completely fine. And then what else did I want to tell you about structuring? Yeah, I think I'm going to stop here because otherwise I can go on for a bit too long. Yes, there is this paper that's kind of good that I kind of like because it highlights how to sort of break down your code for a typical analysis of not just neuroimaging but in general. It's telling you, I think I've put all the sort of simple rules that each analysis step, that's one script. The script either processes a single recording or aggregates across recordings, but it never does both. Sort of goes back to this idea that a function only does one thing. This idea of like you make sure that you have very sort of simple steps. I think further down the line you can have like a single script that tries to run everything. With that one is super important. Make sure that you save intermediate results so you can easily check them and visualize them. And so each parameter and filename is defined only once. That goes back to this idea I was telling you. Try to have what I like a configuration where you can easily change variables to change your analysis. That's kind of super useful. Yeah, so definitely one of those little paper that's kind of good to sort of have a look at to give you pointers on how to organize your project. Yes.
What do you mean by recording?
I think here he was definitely the author. What's his name again? He did it. He is an MEG person. So he was definitely sort of talking about magnetoencephalography type of recording, but apply it to whatever you have, right? It could be it could be neuroimaging data, but it could be something entirely different. So yeah, so I think I'm going to stop here. Are there any questions? Yes.
So you wanted to show us, if possible, how to test the same script or same function in GitHub to see the Mac operating system in Windows or whatever?
Yes, so that would take a lot longer than just like 5 minutes. I can sort of show you quickly how you can start running things. So, okay, I can't exactly show you, like it would take a bit too long to show you the whole thing and how to do it. Actually, can I do that? Okay, I can run you through sort of the logic of it in the repository where the website is. So, if you want to test, if you want to run things, anything in GitHub, so first of all, you need a Git repository, and you need to have pushed your code on GitHub. So obviously, that's like the first step. Actually, you know what? I'm sure we can do that quickly enough. Clean workshop day 2. Let's create a repository. New repository. Look. Oh yeah, I forgot that the limiting factor here is the internet speed. So we're creating a new repository. It's a public one. Let's go with the defaults. I want to push existing repository from the command line. Let me copy all those lines here and paste them here because then it will happen all by itself. Oh yeah, that was the part that was taking so long. So why this is happening? I can sort of start adding files. So I'm going to create a .github folder, and in there I'm going to create a workflows folder. And this is where you're going to put each of the sort of things you want to automate in GitHub, right? And all of those have to be sort of in a YAML file, right? So you can have, let's say that you want to sort of have a YAML file where you're going to define how you want to run the tests. So let's just call it test.yaml. Okay, I'm going to start going from memory, but I'm going to need to check quickly how things are supposed to be named. Okay, yes, so It's on. Okay, I do get some autocomplete because I think I have. That's how I have configured my VS Code. So you need to give a name to your workflow. So here it's just test. Okay, on is the next thing that you need to declare in this YAML file, meaning that you're telling GitHub where you want to run this workflow, and it's going to go. I'm going to run it every time you push to the branch called master. Actually, I don't have my branch. Is actually my main. My default branch is actually called main. So I need to change that here. And on pull requests towards the branch called main, actually, let me change that so it's run on pull request on any branches. So you can just use the star here. So here you're defining the name and when to run the workflow. Then it's telling me that I need to have something called jobs, which are going to describe the different things that you want to do in your workflow. And here you sort of start defining those different jobs. Well, here we're actually going to run some tests, and here it's telling me already a lot of things. So VS Code, the way of computer is like it's giving me like a lot of like pre-configured stuff, and I don't want to go and use all of those, but it can help you get started. So I'm going to just accept those, but actually I don't want all of that. I just want all of those. So the thing that you need to the thing you need to define for each of those jobs that you're going to be running is which operating system. So that's the thing we're talking about earlier, is that here, for Python, for example, here you could say, I want to run it on Ubuntu, I want to run it on Mac OS, I want to run it on Windows, and you can, and latest means I just want the latest version of this operating system, but you could also specify, I want sort of like, Ubuntu, 1804 or something like this, right? So it can sort of change, you can sort of choose that. Once you define which operating system you're going to use for this job, then you need to define what are the things you want to do during this in this job. And the first things here is checkout, meaning you want to sort of GitHub to sort of check out the code from this repository, right? And then you're going to start adding commands on what you want to do. So another thing that, for example, you can run here, I'm just going to do with something very super simple, just so you get an idea of how this would work. I just want to do echo hello world. So if you're familiar with a bit of Linux command line, it's just how you display hello world to the terminal. So here, if I go and do hello world, oopsie, well, obviously I cannot type, then it just displays hello world. And so, because most of the Linux, most of the continuous integration on GitHub is just based on Linux, this is what this is the language you're going to have to be using. And then, just to make a demonstration of all of this, git add all, yes, git commit -m new workflow. Wait, did I miss something? Yes, pre-commit is doing its thing, that's normal. Cool, so that got committed, and now I just need to push. Yep, so now if we go back here and refresh, most likely it will happen way too quickly. Okay, no, see, oops, that was quick, but there's a green tick here that means that the continuous integration has run and has not failed, right? So if you click on this, it's showing you all the different steps that run, and why do I only have pre-commit? What am I missing? Why didn't test run? Ah, no, wait, so that ran, but that failed. Now I'm confused. Oh, this graph workflow invalid type for on. That's when copy pasting just becomes an issue, and that sometimes you should just like, what am I missing? So that's when you just go and grab something that you know works, and you go, wait, isn't that the same thing exactly? Yes, it is. So what did I do wrong? Is it? That's when I start thinking I'm going crazy. So that should be fine. We know that's to be main, and here should be test. Jobs is indented property steps. Yep, another occasion when you get to see me fail live. Okay, that is definitely one thing that is annoying about debugging continuous integration, is that it is a bit of a slow thing, because fix CI, it's a slow process, because you always need to sort of like send the command to GitHub, wait for it to execute and see what went wrong, and ideally add sort of like, yes, so now it's running, I don't know what I changed, I made it work. Honestly, it's one of those where someone like, I don't know what happened. So yeah, so this is running, and now you can see all the different action happening one after the other. So the setup job, I didn't specify it as something that runs automatically. Git checkout, so it's checking out the content of the repository here, and then it's just running the hello world command. Yeah, I'm definitely gonna stop here, otherwise this is gonna last way too long. But the idea is that I will give you, I'm gonna work to sort of make sure you have a clean example of how to run MATLAB code using GitHub, and hopefully for GitLab as well, so you can just decide where you want to run your code. But there are ways you can just definitely do it. It would just take a bit too long to show you all of that now. But that's the idea. How you would work with CI is just like add one command, push, make sure that it runs, and just like go step by step once again.
It's not like uploading a script and then...
Well, it is uploading, because as you push when you push your code to GitHub, you're sort of uploading your script over there, right?
Okay, so we copy, or okay, we write code and then we push.
Yeah, exactly. Yeah. You had another question? Yeah.
Yeah, is there a way to get to warning already in the command line? So because this way we had to go over to the browser and see if it worked. Like, is there a way to see it already when you push?
Not that I know of. Usually what I do is that I have a whole bunch of notifications, I'll get emails, but I won't see it from the command line. My advice usually though is try to write some scripts that you can that you will be able to run equally locally and on GitHub. Meaning that if the only thing that that will happen in GitHub is you run this script to run all your tests or whatever you want to automate, but you should also be able to just run this script on your machine with all the paths being the right one and everything, so that you can sort of do the debugging on the script locally, you can make sure it runs there, and then you're almost certainly sure it will run in GitHub. Yeah, that's usually how I would tend to do things.
Okay, the notification seems like a good solution to me. Like you just have to email program in the background, and then you get
that's usually how I would do it. Very often the good thing about GitHub is that you can run, I think for MATLAB code, you can run stuff there for like up to 72 hours, right? So if you have very long tests that you need to run on very big pipelines and things like this, you can have your test run for a very long time before the thing goes like, okay, I'm out of time. So definitely try to delegate to GitHub things that take longer time that you cannot run regularly on your own. Okay, any more questions? No? Good, okay. Let's wrap it up.